Okay, now you can see that is in terms of the circuit. You can try to play around with the expression. Let's say you have here, this is not, this is OR gate. So it asks you to draw using the NAND gate only. So you have here A input with the NOT. So NOT represent, okay, kita daripada beginning, we have NOT here, and this NOT will be ADD, which is OR gate with our B. Okay, this is our circuit from here. So this circuit, we construct it and use the NAND gate only. Look into your previous slide, how the NOT gate represent. So this is NOT gate, but in term, NOT gate function, but in term of NAND gate. NAND gate to be your NOT gate functions. And you can see here, supposedly you have OR gate. OR gate, but you want to represent using the NAND gate. Check back your previous, you're going to have this kind of circuit. So it will be this is NAND gate, this is NAND gate, this is NAND gate. So there is another one thing that important. This is correct, but you need to also simplify when you have NOT and NOT. A here will be A bar and your final will be A, which is NOT and NOT. Tidak dengan tidak is going to be removed because it is like a direct connection. Here is A, here is also A. So in between, if you have two NOT gate, you're going to remove it. That's why you can see here, you have NOT gate at this part and it connected directly to another NOT gate. You're going to remove these two and your final answer will be like this. So let's take a look in terms of proper way. Okay, you have NOT gate here for question A. Then you present to be the, in terms of NAND gate. And our OR gate here, you represent like this. And when you can see here, when you have this kind of circuit connection, you have NOT and NOT. So you can remove this. So when you remove this, you're going to have direct connection because when you have this also, you have this input as A, and then at the end also it will be A. So it's like a direct connection. So this is your final simplification for the equation A, this one. Then you have another one is question number B. You have A, B bar. A, B bar, okay. This one is AND gate, this is a NOT gate. You represent first the simplest, which is NOT gate. So you draw your NAND gate here. You get your NOT gate. And the AND gate, how the AND gate looks like, it will be A, B. So this is NAND gate. Remember the NAND gate, this is also a NAND gate. When you have two NAND gate, it represent as a AND gate function. So you have like this. So you cannot simplify anymore because you can see here the function, okay? I talk about function. This is not get function. Although it represents as a NAND gate, but the function is not. This function is as a NAND gate. The function, okay, I talk about function, although it is NAND gate. You know also this is a NAND gate, but the function is NAND also. And this part, the function is not get. You can see here, although it's connected to this, just now I thought when you have NAND and NAND, it's directly removed together. But that part is look like this. Which is similar to not and not. But now here you can see in this representation, it is a NAND function. You see here, this is NAND and it's connected to the NAND also, but the function now is not. So that's why you cannot simplify these two. So this is the final answer. And you can try to do this also, use NAND. So you just change this to be your NAND, and another one you have another NAND connections. When you have another one here, it is O. O will be look like this. You need to remember how the O look like. So here you tag it to be at the bottom, so you will get like this. Now you can see in terms of the function, this is NAND, this is not, this is not, this is NAND. And similar to bottom, it's basically similar. NAND, function, not, and NAND. So here you can see not and not are connected to each other. You can remove this, not and not, you can remove, and your final answer will be like this only. So in terms of just now, your friend asked me, okay, how to determine odd and even level. In your question, they will not provide you which is odd, which is even. So starting at the end, which is near to the output, you're going to name it as odd first. After odd, of course, you're going to have even and continue back to be odd and even. And if you have another, it's going to also continues. In this circuit, you still also going to have like odd and even, starting at your output side, not on your input side. Starting on your output, going to put as a odd. Here is even. So when you have another circuit here, this is odd, this is even, this is odd. So normally the question will inform you whether you need to change at the odd level or even level. Of if it asks you to change only at the odd level, you're going to change these two level in this circuit. For this, you're going to change only this if it is odd. But if even, you change this one, isn't it? If there is a question like this. And if they ask you, I guess, in your lab, it mentioned you can select whether you want to change the odd level or even level. As long as if you have like this, if you have this kind of circuit, you need to change all. Let's say you have odd, you want to change only odd, so this odd you need to change, this odd you need to change. If you have another this odd, you need to change all odd. If you want to change even, all even, you need to change. Odd, sorry, odd, even, odd, even. So if you need to change even, so all the even circuit you need to change. You cannot only, okay, this even, although you have another even, you cannot only change one level. Although you can select odd or even, you need to change all. Another one more things. Let me check my WhatsApp first. Already? For another 10 minutes. Tak ada lagi pun announcement. Okay, so similar also at your Nget here, you can see you can have the Nget connection. It's just a bit on the term of connection, and it can be represented as a Nget. And in terms of two connections of Nget, it's going to be OGet. But just now, when you have two NAND gate, you're going to have AND gate. So that is the only difference. NOGET is going, two NOGET, you're going to get OGet. Two NAND gate, you have AND gate. Similar to this part also, when you have three NOGET, you have AND gate. But when you have three NAND gate, you're going to get a OR gate. So you need to remember in terms also on the connection and the representation. And lastly, the four NOR gate will be getting the NAND gate. And for NAND gate, if you still remember, it's going to be your NOR gate. Okay, let's see the example here. Similar example just now, it asked NAND gate, but now it's asked you to do the NOR gate. So similar, you can have this A bar or with the B. So you change this in terms of NOR gate. This is the NOT gate here. And there is another OR gate, then it will be OO. It will be look like this, which is NOR gate here and another OR gate. So you cannot simplify because this is a NOT gate function, this is NOR gate function, this is a NOT gate function. So this is the final answer for this circuit. Look in the proper way, you can see here. NOT function, all function all together, but represent in terms of NOR gate plus with your NOT gate to be your OR gate. Now you have this another example. You can see here when you have NOT, you represent like this, and this is all your AND gate represent by using your NOR. And you can see here, you can simplify this. That's why you're going to get the final answer like this one. So if let's say it asks you to change in terms of like odd level, you're going to change these two. If it asks you to change the even, you're going to change these two. Okay. Next is on dual symbol. Okay, in terms of dual symbol, we're going to see for NAND gate and NOR gate, it can be also represented using the negative O. How negative O look like? You have a O there, your normal gate O, but you put the bubble here. What is a bubble? It is a knot. So knot is a negative. This one is negative. You can also have a lot of knot depending on how many input you have. Still, this is negative or. Then, if you have the NAND gate like this one, okay, if you have no gate, it should be represented as a negative and right. Okay, we look into this example. Let's say the question asks you, change the odd level to use the dual symbol. So you need to know if it is a no gate, you're going to have negative n, negative n gate. So it's going to be changed only odd level. This is the odd level. So I change it to be n, but it will be having the negative there. It's connect to this no, because this one is not changing. I just change the odd level A, and then there is a B like this. So this is the things that you change. So you can see here, this bubble is what? Not. This bubble is what? Not. So if only, you need to do step by step. This step is okay, correct. But in terms of simplification, you can also simplify this. Then you're going to have the N, the O gate there, add with your negative. So it's supposedly like this one. But in terms of final, alamak saya dah delete pula. In terms of final, you can also put there like this also can. Because it asks you to change only in terms of the dual symbol for this odd level. If the even level, you just change this to be the negative n. So that is the things over here. That's why you need to remember what is the representation. Nan to be negative or no to be the negative n. Okay, when you have this, just now I already mentioned, if you have the bubble, you can cancel. So in terms of this theory, you can use it later on to put in your circuit to just help in the simplification. Okay, you can go through this one, but I like to give you direct example, right? Okay, from here it asks you convert this SOP. What is SOP and or logic? Convert SOP circuit, you know already, SOP circuit to NAND only. Okay, if you remember, you have two way. One way you already learned, which is in terms of representation. Just now you learn if you have AND gate, you can have a NAND gate representation. This one, okay, AND gate, it will be like this. If you remember, this is your representation of two NAND gate to be your AND gate. Look back your module previous slide. Okay, you can see here, this is your AND gate. Okay, another one you have AND gate also. You're going to do similar things. Because the question asks you to use only NAND gate. Then you have NAND gate here. This one is Nand Gate, this one is Nand Gate, this one is Nand Gate. In terms of function, this is NAND function, this is not function, this is NAND function, this is not function. Okay, right? Then combine it together, it's going to be a AND gate. AND gate also here. So you're done at these two. OR gate. OR gate, how to convert to NAND gate? It's going to have 3. Kenapa saya buat ni pula? If you still remember, this is the representation for your OR gate using your NAND gate. Look back in your previous slide. It's supposed to be like this. Then you done. This is all NAND gate. Correct. But you can see the function to simplify it. It's supposedly to be like this. Not and not. You simplify. Not and not. You simplify. You will have this final answer using your NAND only. Okay, this is one way. Because you already learned this one, I just repeat it back. There is another way, which is just now you learn on the bubble thing here. You know that this one can cancel each other. So, what is the purpose? When you have this one, this is your AND gate. How is supposed to be NAND gate? NAND gate, it just add another NOT, isn't it? When you add another NOT here, you cannot just add this one when you have 2 NOT, which is it's nothing happen inside your circuit here. So this is the things that you need. So you need to add another NOT. Similar here, when you have this NOT, it doesn't affect your output. It doesn't affect inside of this circuit. So that's why this another second way. One way you just learned just now, and another one is using your bubble thing. You put NOT and NOT. So it doesn't affect, it just want to help you to change later on to be NAND gate. You put another NOT here, you need another NOT. In one line, NOT and NOT, it simplify, right? But you want to add it to change to be NAND gate. That's why you put NAND and bubble, which is NOT and NOT. Okay, now you have here, this is already NAND gate. This is already NAND gate. So I don't want to look over here anymore. But this is my problem. I have a negative OR here. Look back at my previous slide. Negative OR is similar to my NAND gate. So I can just change this to be my NAND gate also. So I get my full NAND gate representation from this. Like just now, it is a N and O. In terms of NAND gate, I can represent like this. Your output should be similar. You can go and check your output. Go and check in your DIT simulator. For here, you will get the answer similar. Your truth table should be similar. In terms of representation, only different. How? You use this bubble way. You put the bubble here. Supposedly, you're going to put 2. Then it can cancel each other. You put here, you need to put another one. This is your NAND gate already. This is your NAND gate already as required. And this is negative OR and similar to also your Nand Gate. So you have full correct marks there. What? 9:05 dah. Nanti saya lambat. Sekejap saya check. Kenapa tak ada pun orang cakap? Mana dah? Supposedly. Okay, dah mula 20. We'll start tomorrow. Hari ni sampai 9. 9 sampai 5. Okay, I need to go. So what we're going to do, okay, you have another 1 hour. What I suggest you to do is you conduct your lab 2 with your friend and then try to finish as soon as possible. Okay, if you have any question, because yesterday there is a lot of students ask me, especially for part B, you can ask me, but I'm going to give you only a hint. I want you to construct your own like truth table or your comment for the situation, because your test 2 much more harder if you compare to the lab 2. If you cannot do the lab 2, you cannot answer your part B test 2. So please make sure carefully you fully understand. That's why yesterday we look into the step. I mentioned the critical part for problem statement is at your step number 1, which is to understand. Okay, I need to go. It's already 9:07. I'm the only, I guess, lecturer coming late. So sorry. We dismiss our class, but you cannot dismiss, which is you need to continue with your friend. Okay. So thank you for your participant. Stay safe and meet you again in next class. Bye bye.
Thank you, Doctor.
Okay.
Thank you, Doctor.
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 Doctor.
Okay. Dah ikut. Boleh dekat sini je. Nanti Mama akan buka kamera ni. Ikut lagi ke?